First of all, let's talk about the FAA flexible pavement design method. So basically you can see the FAA pavement design method in FAA documents, especially in advisory circular. So this is the advisory circular that talk about the pavement design method from here until here, and this is the time historical about the advisory circular that discuss about the pavement design method. So they have developed the advisory circular from A 6A to 6F because time flies and knowledge also develop, so they should have to make it update from 1995 to 2016, so they should have to update. And because of from 1995 to 2016 is around 20 years, so of course, as you can see here, they change the method. So from 6ABC until 6D, they use pavement design using old FAA method, or the old FAA method is equivalent aircraft method. So from 6A to 6D, they use equivalent aircraft method, and from 2009 or 6E until now, they use pavement. They use FAARFIELD, or maybe we can see it far field software, or cumulative damage failure method. So in this meeting we will also talk about the equivalent aircraft method, or the old FAA method, and also we will talk about the far field software that using cumulative damage failure method. What is the difference between the equivalent aircraft method and the cumulative damage failure method? So for the equivalent aircraft method, or the old FAA method, also known as the CBR, this is for the flexible pavement design. So they also also known as the CBR method. And the CBR method for flexible pavement was based on approximation charts. So we will use chart basically that factored in the CBR value of the subgrade and the number and gross weight of equivalent annual departures of the design aircraft. So basically we will just use the charts like this. So this is the charts. We will have the CBR, and this is for the gross weight of the design aircraft, and this is for the equivalent annual departures. And after we input all of the variables, we will get the thickness of the pavement here. I will explain how to use the charts later. And for the far field software, or cumulative damage failure method, is a method of design based on layered elastic and three-dimensional finite elements based structural analysis developed to calculate design thickness for airfield pavement. So for the far-field software, uh, the method is also upgraded. They use layered, elastic, and three-dimensional finite elements. As you know, the finite elements is a little bit complex to calculate manually, so we need a software to calculate the finite elements. And because if we use the old FAA method, we will depend on the charts, and the charts is different uh, for any configuration wheel. So if uh, nowadays the wheel configuration of an aircraft is really complex and not as simple as the old time, so we need a software that can be applied to all new complex gear and wheel arrangements. So far field is the meaning is FAA, rigid and flexible, iterative, elastic layered design. So this is the difference between the old FAA method and the far field software. Now we will talk about the old FAA method, or the equivalent aircraft method. So the old FAA method was developed in 1975, and this historical method involved determining the number of total annual aircraft departure by each type of aircraft and group them into equivalent annual departures. So as we know that in an airport there are so many types of the aircraft. Basically, uh, there are many kinds of aircraft in the wheel configuration. For example, single wheel, dual wheel, double dual tandem, and etc. So they have they will be in a different units. If we want to calculate it, we should have to make sure that they have in the same unit. So what will what we should have to do to make sure that they are in the same units of the wheel configuration. So the group is based on converting the number of annual departures of all aircraft other than the design aircraft to an equivalent number of annual departures by using the multipliers given in this table. So we have a design aircraft, so we should have to turn or convert the other type of the aircraft to converting to the design aircraft from so for example, if we want to convert from the single wheel type to dual wheel type, so we should have to multiply it with 0.8 like this. And also for this is for the table to converting the number of annual departures. After that, the equivalent annual departures of the design aircraft were determined by summing the equivalent annual departures of each aircraft in the group by this equation, where the R1 is equivalent annual departures by the design aircraft, and the R2 is the annual number of departures by an aircraft in terms of design aircraft landing gear configuration, and the W1 is the wheel load of the design aircraft, and the W2 is wheel load of aircraft being converted. So we should have to convert into the design aircraft type. To make it easier you to understand about the equivalent annual departure, so I will give you an example. The question is, please determine the equivalent annual departure of design aircraft based on following forecast traffic. So this is the following forecast traffic that contains the data of the aircraft that will be served by the airport, and this is the gear type of each aircraft, and also we have average annual departures for each aircraft, and the last is we have the data of MTOW, or maximum takeoff weight. So for the calculation of the pavement design, we will use the MTOW, or maximum takeoff weight. Why we use the MTOW? Because the MTOW is uh, higher than the MLW, or maximum landing weight, because in MTOW the fuel is still full, so it will be higher than the MLW. So we will use the MTOW for the pavement design. So the answer is, first, you should have to determine the design aircraft. So in this example, the design aircraft used is the 727-200, or this will be the design aircraft. Actually, if you want to determine the design aircraft, there are some calculation to make sure that you choose the right design aircraft. If you want to determine the design aircraft, you should have to calculate for each aircraft which one uh, that needs the greatest pavement thickness. After we calculate each of the aircraft, uh, we will get the greatest pavement thickness, and for this example is the aircraft type 727-200 here. So this is the design aircraft. Next is group forecast traffic into landing gear of air design. So in this example, the design aircraft, or the 727-200 aircraft type, has the gear type, has dual gear type. So in this example, all traffic must be grouped into the dual wheel configuration. So because of the design aircraft has a dual gear type, so you should have to convert all of the others aircraft into the dual gear type. So for example, we have this type, this dual tandem gear type and double dual tandem gear type, so we should have to convert it into dual gear type. So how we convert it? So for example, for 707 320B is 3050, like this. So the average annual departures is multiplied by 1.7. So the 1.7 we get it from the table in the slide before, so we should have to multiply it, and we will get 5185 here. And we also calculated from for this aircraft type, and also this aircraft type, and this we won't calculate this one, and this one, because they have the same gear type and dual gear type, so we don't have to convert it. So this is the table for this column: aircraft, gear type, average annual departures, and the MTOW is from the question, and this is what we will get: equivalent dual gear departures, wheel load of design aircraft, and equivalent annual departures design aircraft. This is what we want to get in the end, and this is what we calculate before. For example, here, so for the aircraft 727-100 with the dual gear type, and the average annual departures is here, so the equivalent dual gear departures is the same as the average annual departures here, and also for here. Why? Because the aircraft design is 727-200, and they have the same gear type, so the equivalent dual gear departures will be the same like the average annual departures. So, and also for this is also the same as the average annual departures, and also here, but we should have to convert the dual gear departures from the average annual departures for the dual tandem gear type and double dual tandem gear type. So here, so if we want to get the equivalent dual gear departures, we should have to multiply the average annual departures here, 3050, multiplied by 1.7, and we will get this. And as for this, we will get it from 400 multiplied by 1.7, we will get this, and etc. So the multiplied is based on the gear type. In the slides before, you can see that from the table, the multipliers. So then we should have to calculate the wheel load and the wheel load of design aircraft. So how we get this? So for example, wheel load for 727-100 here, we will get it from 0.95 multiplied by 4 multiplied by MTOW. 0.95 here is based on 95%, so this is will be the same for all of the calculation, 95%. And for this number 4. Why we use 4? Because the number of wheel in dual wheel is 4. The dual wheel is the gear type in the aircraft design aircraft, so we use dual wheel. But if sometimes uh, the design aircraft is a different aircraft type in a different gear type, so we should have to change this number. It's not 4 but maybe 6 or 8 or etc. So it is based on the gear type of the aircraft. So for this example, we will get the wheel load from 0.95 multiplied by 4 and multiplied by maximum takeoff weight, the MTOW. We can get it from here, and we will get 38,000 here, and all of this is multiplied by 0.95 and multiplied by 4, and we will get this wheel load. The next is to calculate wheel load of design aircraft. We use the same calculation, we use the same equation like the wheel load, but the difference is the MTOW here is from the design aircraft, and because of the design aircraft in this example is 727-200, with the MTOW is here, so we just put it the MTOW like the same amount like this, and we will get this number here, and all of this is the same because the design aircraft is the same, so we will get it as the same amount of number. So the last is we should have to calculate the equivalent annual departures design aircraft. So we will use the equation here like I have said in the slides before. So we should have to calculate it. So the R2 is this one. The R2 is the equivalent dual gear departures here, and the W2 is the wheel load, and the W1 is the wheel load of design aircraft. So we just make the calculation here, and after we make the calculation, we will get that the R1 or the equivalent annual departures design aircraft is 1,800 and 1,891 here, and you should have to calculate for each aircraft type here, and after that we just sum all of this equivalent annual departures design aircraft, and we will get the total number is 16,241. So for the final result, so for this example, the pavement will be designed for around 16,000 annual departures of dual-wheel aircraft weighing here 100,000 and 90 and 500 pounds, and the design should, however, provide the heaviest aircraft in the traffic mixture of B747-100. Where will we get this? We will get this from this. The largest or the biggest MTOW is from the aircraft type 747-100. When considering depth of compaction, thickness of asphalt surface, drainage structures, and etc. So this is the final result. The 16,000 annual departures is, we get it from here. Dual wheel aircraft is depend on the design aircraft, because the design aircraft in this example is 727-200 and the gear type is a dual gear type. So this is a dual wheel aircraft, and the weight is from the MTOW of the design aircraft, and this is the biggest MTOW aircraft type.